Lesson 4.7, solving systems of equations with elimination using addition or subtraction only. Substitution was an effective way for solving a system of equations with no coefficient on one of the variables, but it can be complicated if the system has coefficients on all of the variables, because when that happens you have to solve for a single variable and you can get fractions or decimals, which can make the equations more difficult to work with. So what we can do instead is we can use elimination by addition or subtraction with or without multiplication. In this lesson, we'll only use addition and subtraction with no multiplication, and in the next lesson, we'll incorporate the multiplication. So in order to solve a system with addition or subtraction, we need the following: a system of equations, and at least one variable to have the same coefficient on both equations. So here's how this will work. We have two separate system of equations here. For the first step, we're going to identify the variable with matching coefficients. So looking at our first system, I have a 3x and a 2x, and I have a y and a negative y. That's an invisible 1, so these are our matching coefficients. In our second equation, I have 4x and 4x, so these are our matching coefficients. Step 2 is we need to determine if we need to add or subtract to eliminate that variable. So from now, we'll just work with the first system. After we solve this one, then we'll come back and follow all the steps to work with the second system. So looking at the first, I have a 1 and a negative 1. If I add, these will cancel each other out. So I'm going to add these two equations together. When I add x's, I add y's, and then I add the constants. So 3x plus 2x gives me 5x. Positive 1 and negative 1 cancel out. So I have no y's. 10 and 15 is 25. So I added to eliminate the variable, and now I need to solve the remaining equation. The remaining equation is 5x equals 25. So what I need to do now is divide both sides by 5. That leaves me with x is equal to 5. Once I've solved this, I plug that solution into one of the original equations, here or here, and I solve for the remaining variable. I can choose either one. I can do 2x minus y or 3x plus y. I'm going to go ahead and use 2x minus y just because it's smaller. I take this solution, x is 5, and I plug this 5 in for that x. That gives me 2 times 5 minus y is equal to 15. So I have 10 minus y is equal to 15. Subtract 10 from both sides, and you get negative y is equal to 5. Because I have a negative y, I don't want to know what negative y is. I want to know what y is, so I change both signs. So y is equal to negative 5. And then I put the solutions into coordinate pair format. So I have 5, negative 5. This is the solution to this system of equations. Now we'll work on our second system. I have both positive 4x's, so if I add, I'm going to end up with 8x, so I need to subtract. Subtracting means I subtract this entire equation, which is actually going to change all of the signs. So I'm going to rewrite this. And what I'll have is 4x minus 3y is equal to 24. And then negative 4x minus 5y, negative 16. What I did is I distributed the negative. So I have 4x minus 4x, that leaves me no x's. Negative 3 and negative 5 is negative 8. And then 24 minus 16 is 8. Divide both sides by negative 8. And I have that y is equal to negative 1. Now I pick either equation, doesn't matter which. I'm just going to pick the first one this time. I plug this -1 in for y, so I have 4x minus 3 times -1 is equal to 24, which gives me 4x plus 4 is equal to 24. Subtract 4 from both sides, and I get that 4x is equal to 20. Divide both sides by 4 to get that x is equal to 5. And my solution to this pair is 5, -1. That is the solution to this system of equations. So these are the steps that you'll follow. Maybe draw a line between here so you can see where one part ends and the next begins. Maybe double line. Okay, so let's try a couple more. Okay, I have set x minus y is equal to 3 and 7x minus y is equal to -3. My y's have my matching coefficients. And since they have the same sign, I'm going to need to subtract one of these equations. So I'm going to subtract this one. Distributing that negative gives me -7x, positive y, and positive 3. So x minus 7x is -6x. The y's will cancel, and that gives me a 6. Divide both sides by -6, and I get that x is equal to -1. I can choose either, but I'm going to go ahead and use the first one. So I have x minus y is equal to 3. X is -1, so -1 minus y is equal to 3. If I add 1 to both sides, I get -y is equal to 4, which gives me y is equal to -4. And my solution is -1, -4. Now what I would like you to do is pause the video and work out these two. When you're finished, unpause the video and compare your answers to mine. I'll have all the work here and see if you're able to follow the steps properly. If not, pause the video again and check your work. Okay, so check your work. The second example came out nice, even integers, but the third example, you had fractions to deal with, or if you converted it to a decimal. This is when solving with elimination becomes more useful than, for example, graphing, because I end up with -20 thirds, 43 sixths. If I used decimals, I would have -6.7, and then 7.17. So if I was graphing this, I would not have come up with this solution because I wouldn't have hit a whole integer. So double check your work and see if you made a mistake, if you can find the mistake. Now I worked this out with the fraction, but you could have also worked it with the decimal.